Hello and welcome to a new video for Algebra 1. This is Lesson 2 of Unit 5, a short unit about functions. So we introduced functions last video, and now we're going to talk about function notation, which is a fun thing to say because it kind of rhymes. So let's go ahead and take a look at what's going on with function notation. So there's a helpful way that we can write equations, specifically equations that are representing functions. But it's a bit tricky to understand at first. Here's what it might look like. Now we're used to seeing something more like either a number equals 4x minus 3 or maybe y equals 4x minus 3. But here we have f parentheses x, close parentheses. Now you may be thinking, well, f and x are next to each other, so this must mean that we're multiplying two variables together. That would not be what's happening here. This is a very special notation that's recognized as meaning something that is not how anything else works, right? In any other situation, yes, f parentheses x, like that would mean multiplication. But because we have this function notation, we know that this is actually saying instead f of x, which means we have a function and we're naming it f, and that function f has the variable x. And so just those, two letters in parentheses are telling us something about this particular function that is helpful if we want to start thinking about the function more. So it's not multiplication. You read it f of x, which is ironic because of means multiply in math, but we just say f of x equals blah, blah, blah. And it's not multiplication. So we don't divide by f or divide by x. You can't separate those two things in a way of trying to manipulate the equation. It's almost like f of x is together a single thing. Now, here's how we use it. First, we can use it to name equations. So if we just have a whole bunch of equations that all say y equals, but we wanted a systematic way to name those equations, we haven't had something that we could do with that before. I suppose we could do y1, y2, y3, and so on. There's another way we can do it. We can use function notation. So here we have two functions. One of them has f at the front. One of them has g. I assume that the reason f is popular for function notation is because f, function starts with f, but the backups tend to be g and h. If you're seeing other functions being named things, we typically use f, g, and h. So here we have two functions, one we've named f and one we've named g. So we can refer to those functions as their names, f or g. The other information it tells us inside the parentheses is it tells us what variable is important on the right side. And for a while, we'll only ever be dealing with one variable on the right side, but eventually we can end up with more than one variable on the right side, and that would complicate things. So let's not worry about that right now. So f of x is saying, hey, this is a function f, and we have an x on the right side. So if you wanted to graph this, for instance, you would plug things into x. That's kind of what it's saying. For the second one, g of a, we've named it g, and it's saying, hey, a is the variable that's on the right side. So that's me trying really hard to break down what this notation is saying. Here's what we're going to do with it. If we have an equation, or more than one equation, we can find these values. So it says f of 2, g of 0, and f of negative 2. That's how we would read that. What it's asking us to do is plug in these numbers where x is. But what's cool is that the way we label them, it tells us what we're plugging in. Here's what I mean by that. When we do f of 2, normally there's an x here where this 2 is, but we've replaced it with a 2. So what we're going to do is we're going to write 4x, but instead of writing x, we're going to put a 2 there instead. So f of 2 is asking, what do you get for this function when you input 2? What's your output that you get? So we plug in 2. 2 times 4 is 8. And so then one of the ways we can write this is to just say, hey, f of 2 is 8. And someone else who is a math person who knows what's going on with function notation would look at this and go, oh, I see, you plugged in 2 and you got 8. You're giving them information in a way that they can understand. The second thing says g of 0. Notice there is an f and a g, so we gotta pay attention to which one we're using. G of 0, we want to put 0 right here where this x is next to the negative 2. Negative 2 times 0 is 0. So g of 0 is 0. So the math in this lesson, I'm not intending for it to be overly difficult, because the difficulty here is wrapping your head around the notation. So early on, one of the suggestions might be that you just kind of think of it as a fancy y. Even fancy starts with F as well, so a fancy y. Because that's essentially like, we could have had a situation where these were both labeled y, right? It's just that we named them F and G so that we would be able to tell them apart more easily. Anyway, f of negative 2, let's plug in negative 2 for f. Well, we're plugging it in for the x in the function f. So 4 times negative 2 is negative 8. So f of negative 2 equals negative 8. So see how nice my answers look and how much information they give you, because they tell you which function it was plugged into and what we plugged in and what the answer is. It's pretty awesome. Example 2. So now we've got g and h. We've got some things to plug in. So g of 2, well, g of x is x squared, so we just need to do 2 squared. 2 squared means 2 times 2, so that's 4. So g of 2 equals 4. Let's find g of negative 2. So we're going to square negative 2. Now, when we square negative 2, we're saying negative 2 times negative 2, which is a positive 4. And the way we're supposed to write this when we plug negative numbers in for x, we're supposed to put parentheses around it to help us remember that it's not just the 2 that's being squared, it's also the negative part of the 2 that's being squared. And so it's kind of a thing that's important. Also, because if you were to put this in the calculator, if you put in negative 2 squared, that is different than if you put in negative 2 squared, even though I just said the same thing, right? So that's one of the reasons why I have parentheses here, is it's just kind of correct notation to help ensure that you get the right answer, even if you use a calculator. Let's see, let's do h of 2. So negative 3 times 2 squared. Order of operations says to do exponents and then multiplication. So this is negative 3 times 4, which is negative 12. So h of 2 is negative 12. Then we're going to do h of negative 2. And this similar thing is going to happen here. We got to square the negative 2, which gives us positive 4. Negative 3 times 4 gives us negative 12. H of negative 2 is negative 12. Now remember we talked about that functions have, every input has a unique output. Has exactly one output, actually. So even though g for 2 and negative 2, we got 4 for both of those, what matters is that g of 2 only gave us one answer and g of negative 2 only gave us one answer. You might be wondering, how would I even get 2 answers if I had an equation? And it's actually pretty hard to do. Not impossible, but hard to do. So it's going to look weird if somebody's trying to give you an equation that's not a function. And if you see it with this notation, f of x or g of x or h of x or whatever, you can pretty much you can assume that it's a function, because they wouldn't use function notation unless it was a function. Final example here, we've got f of x is square root of x and g of x is 5 square roots of x, and we're going to find some things here. So remember that square rooting something is where we say what times what equals that thing. So the square root of 1 is 1. So f of 1 is 1. F of 9 is the square root of 9. So the square root of 9 is 3, because 3 times 3 is 9. So f of 9 is 3. Okay, g of 4. Now notice that g is a little bit different. 5 times the square root of 4. Square roots are actually in the same category as exponents, that we would square root the 4 first and then times by 5. So the square root of 4 is 2, so we'll do 5 times 2, which is 10. So g of 4 equals 10. And then we'll do g of 0. So 5 times the square root of 0 equals 5 times 0, which is 0. So if you're having trouble with this, feel free to leave a comment, ask a question, or whatever it might be. We're essentially just taking these things inside our parentheses, right? And we're putting them where our x's are over here, so that we are putting 1 in the place of those x's. We're plugging it in. Thanks so much for watching. I hope you'll leave a like and maybe a comment, and definitely subscribe if you haven't already. I'll see you in the next video. Bye.